So here we have the ambiguous case. In other words, we have two sides in the following angle. That's ambiguous because those two sides in the following angle can often lead to two different triangles. So let's see, alpha would be 65.5 degrees for alpha, so I'll try and draw an angle that looks 65.5 degrees here. So 65.5 degrees, and then A would be across from alpha. So A is 88, and the question is, does A swing out to the right like this, or should A have swung in? Because we could draw the same 65.5 degree angle, but this time have A swing in. So that's why there's two cases. Okay, so let's see, B will be this 95 because I don't want B to change, so I don't want B down here. This will be our C. And then beta is across from the 95, and gamma is across from C. So there's two cases. We have case 1 and case 2. So let's use the law of sines. So the law of sines says the sine of 65.5 degrees divided by 88 equals the sine of beta divided by 95. So you can cross multiply, and when you do that you find the sine of beta comes out to 0.9873. If you use sine inverse in your calculator, sine inverse of 0.9873 equals 79.22 degrees. Now the thing is, there's two angles whose sine is 98.73. There's the 79 degrees that we just found. I'll just put 79 because it's a tight fit here. So then opposite over hypotenuse is 0.9873 over 1. But in the second quadrant, there's another angle with the same reference angle, 79.22 degrees. And it also has sine 0.9873. So it's also 0.9873 over 1. So we find this other angle by taking 180 degrees minus the 79.22 degrees. And that's the other case that we're looking at, where angle beta is 100.78 degrees. So let's look at our pictures. It looks like case 2 would have beta equal to 100.78. That looks like an obtuse angle to me. And here I would have 79.22 degrees. So we have case 1 and case 2. So for case 1, I'll go ahead and find what gamma would be. So I'll just subtract the angles that I have. 180 degrees minus 65.5 degrees minus 79.22 degrees. So that would give gamma equaling 35.28 degrees. On the other hand, in case 2, gamma would also be 180 degrees minus 65.5 degrees minus 100.78 degrees. So that's kind of squishy. But at any rate, gamma would come out to be 13.72 degrees. So we have gamma for each case, and then we use the law of sines to find C for each case. You can see in your picture that the C's would have different lengths. So we say sine of 65.5 degrees over 88 equals sine of gamma, so sine of 35.28 degrees over C. And you cross multiply and find C. When you do that, C comes out to be 55.86. And then we can do the law of sines for case 2 also. So we'd have sine Sine of 65.5 degrees over 88 equals sine of 13.72 degrees for gamma this time over c. When you cross multiply and find c, you'll see that it's 22.93. So there's two cases whenever you have an angle and then the following two sides, because that last side could swing out like we did here with the 88 in the case 1, or it could swing in like it did here with case 2. If there's not two cases, then as you're working you'll get a sine value that's impossible, and your calculator will say not in domain or something like that as you're working the law of sines.